All right, guys, we're going super high tech here, paper and marker. And I'm gonna walk you through dimensional analysis for why we have two different R values when we're doing all of our equations. So here's the deal, the R value, the universal gas constant that we've been using, the units have been liters times atmospheres per Kelvin times mole. Right? So what I'm going to do is I'm going to break these down to their base units, right? So liters, that's like a unit of volume, which are measured, like the base units are cubic meters, right? So instead of writing liters, we can write meters cubed. In atmospheres over here, atmospheres are basically measuring pressure, right? And what is pressure? We all know that pressure is force per area. And the way that we measure force is by newtons, and area are square meters. So Newton is the base unit of force. Meters squared, that's how we measure area. So what I'm going to do is I'm going to rewrite liters in its base units, and I'm going to rewrite atmospheres in its base units of Newton per meter squared. Okay. So what I will get is the liters turn into cubic meters. The atmospheres are going to turn into newtons, and in the numerator and in the denominator, I'm going to have square meters. And I'm going to have left in the denominator my Kelvin and moles. So that's times Kelvin times moles. And there's my line here. It's just a little offset because I'm kind of going, just trying to like simple it down. Do you understand what I'm saying there? All right, so we're almost there, but I don't want to cancel stuff out just yet because I have one more thing. I have this Newton, right? So this Newton is measured in force. And how do we measure force? Force equals mass times acceleration, right? And so we know that mass is in kilograms and acceleration is meters per second squared. Those are the base units. It's really the only three things we can actually measure are mass, distance, and time. So there's that. So what I'm going to do is rewrite the newtons in its. I'm going to rewrite newtons in its base units of meters per second squared and kilograms. You got it? Okay. So the meters are gonna, or these cubic meters are going to come down here to. Force, that's going to be mass is kilograms, so that'll be meters cubed. Newtons is let me just clean this up here. Kilograms per second squared. That's what the newtons are going to turn into. Okay, so I'm going to have kilograms. That's my mass. My acceleration. I'm messing this all up here. My acceleration is meters per second, so mass is the kilograms. Acceleration is meters per second squared, right? So that's everything on the top. Down here, I've got leftover. I still have squared meters. I've got Kelvin, and I've got moles. Oh, let's go like this. So what I did is I took my newtons, which is mass times acceleration. Mass is kilograms. Acceleration is meters per second squared. I'm sorry, mass meters per second squared. Yeah, I'm left over with my square meters over there from, I think that was, what was that? That was like pressure. That's where I got that meters, Kelvin and moles. Does that make sense? So now I'm going to squish these all. I'm going to squish these all together, and I'm going to end up with. I believe I'll have meters to the 4 times kilograms. And that's in the numerator. And in the denominator, I will have, what do I have here? Seconds squared, meters squared, times Kelvin, times mole. Dig? All right, so now I'm going to kill some of those meters there. I will be left with meters squared times kilograms in the numerator. And in my denominator, I'm going to have seconds squared times Kelvin times mole. Does that make sense? Do you see how I broke that down? Now this is the fun part. Meters squared times kilograms divided by square seconds. These can be written as joules. Those are the base units for joules, my friends. So when we rewrite the unit for this particular gas constant, it is going to be joules per Kelvin times mole. J. Now here's the thing here, guys. You see this right here? I need you to recognize that, because that's what's really going to be the like the thing that's a pain in the butt. So they rearrange it like this so that we don't have to do the dimensional analysis every single time. So the second gas constant that we're going to be using is going to be in the units of joules per Kelvin moles. But the problem is that this joules has kilograms. So what that means for us is that in our gram formula mass for our molecules, we cannot use grams per mole. We have to use kilograms per mole, because that kilogram is captured into joules. You got it? Hope so. And we're going to find out.